In the last video, we talked about sequences and having a general rule for them. So we have things like a sub n equals 3n plus 7, okay? And you could plug in an n value and get back some value of a term for that sequence. Today we're going to be working again with sequences, so a list separated by commas, except we're going to be talking about recursive sequences. And a recursive sequence is a sequence that depends on the previous term. One of the most famous recursive sequences is called the Fibonacci sequence. It has to deal with part of finding the golden ratio. It deals with Donald Duck in Math Magic Land, if you've seen that video. If you look at the painting that's outside of the math office, the one with the elephants, the golden ratio is all in there, and it all connects with Fibonacci and the recursive sequence. So, just a refresher from before, if we're talking about an explicit formula, that's where we're given things a sub n equals something that is dependent on n. And we evaluate these things just like we would with a function and plugging in an x value. So a sub 1 is going to be equal to 4 times 1 plus 2, which means that that is equal to 6. A sub 2 then is 4 times 2 plus 2, which is 10. 4 times 3 plus 2, which is 14. 4 times 4 plus 2, which is going to be 18, and then 22. So the first 5 terms of this sequence are 6, 10, 14, 18, 22, comma, dot, dot, dot. Okay? And that's based off of this, again, explicit or general rule. But we can also define sequences recursively. And as I mentioned in the intro, a recursive sequence is a sequence that depends on the previous term. Okay? So in order to define something recursively, you're going to need to know some sort of a rule that is based upon a previous term in the sequence. So for instance, find the first 5 terms given a sub 0 equals 3 and a sub k plus 1 equals 2 a sub k plus 3. This is defined recursively because the next term in the sequence, remember n plus 1, or in this case k plus 1, the next term in the sequence depends on what a sub k was. It does not depend on an input of n. It depends on this input of the previous term. Okay? So we have this rule. You can't do anything with this rule unless you were also given some sort of an initial condition or some term that exists in the sequence already. So if I want to find the first 5 terms, that means I'm looking for a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Okay? So a sub 1 is going to be equal to 2a sub, well, if this is equal to 1, that means k had to be 0 plus 3. Well, luckily, they gave me a sub 0 is equal to 3. So this is really equal to 2 times 3 plus 3, which is going to give me an answer of 9. Now, a sub 2 is going to be equal to 2 a sub 1. So the previous term, well, we just found a sub 1 is equal to 9. So this is really 2 times 9 plus 3. 2 times 9 is 18, plus 3 is 21. A sub 3 is going to be 2 times the previous term, which was a sub 2, plus 3. Well, the previous term, a sub 2, we just found was 21, plus 3, so that's going to give me 45. A sub 4 is going to be equal to twice a sub 3 plus 3. Well, we just found a sub 3 was 45. So that's going to be 93. Finally, a sub 5 is going to be equal to twice the previous term, which would have been a sub 4. This is going to be 2 times, we just found that, 93 plus 3. 2 times 93 is 186, plus 3 is going to be 189. So our 5 terms in our sequence are going to be 9, 21, 45, 193, 189, comma, dot, dot, dot. Okay? So every term was dependent on the previous term. That's what we mean when we say recursively. So, given a sub 1 is equal to 3, and a sub k plus 1 is equal to twice the previous term minus 1, I'm going to help you find a sub 2, and then I'm going to have you guys try to find a sub 3, 4, and 5. So, a sub 2 is what we're looking for. That's going to be equal to twice a sub 1 minus 1. Well, we know that a sub 1 is equal to 3. So 2 times 3 minus 1 is going to be equal to 4. Go ahead and pause the video and try to find a sub 3, a sub 4, and a sub 5 on your own. Alright, so hopefully you came up with 6 and 10 and 18. So a sub 3 would have been 2 times 4 minus 1. 4 minus 1 is 3, times 2 is 6. This then would have been 2 times 6 minus 1. This would have been 2 times 10 minus 1. So to write this as a sequence, it would be 4, 6, 10, 18, etc. Alright, so now, given 8, 11, 14, 17, we're going to try to work to see if we can write a rule for this sequence. Well, recursively in this case is actually going to be a little bit easier. If you try to figure out what the pattern is between 8, 11, 14, and 17, hopefully you can see that you are adding 3 each time. So recursively, I know that a sub 1 is equal to 8, right? You have to be given that starting condition. And then a sub n plus 1 is going to be equal to whatever that term was plus 3. So if you try that, looking for, let's say, a sub 2, that should be equal to a sub 1 plus 3. Well, a sub 1 was 8. 8 plus 3 is 11, and our second term was 11. So recursively, we could define it using this rule. Explicitly is going to take a little bit more work. So we know that we have this common difference of 3, right? We're adding 3 every time, or if you go down, you're subtracting 3 every time. So adding 3 each time, but we're starting with 8. So when n equals 1, we need to get an answer of 8. When n equals 2, we need to get an answer of 11. Well, we know that our difference, like I said, is going to be equal to 3. So we're going to take 3 times our number, n, but 3 times 1 is only 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So right now I'm just at 3, 6, 9, 12. That's not the right sequence. How am I going to go from 3 to 8, 6 to 11, 9 to 14, 12 to 17? Hopefully you said that you're going to add 5. This would be our general or our explicit rule that's based solely on n. We're going to spend a lot more time figuring out how to write explicit and general rules, so don't stress too much about that. Recursively, though, hopefully you're okay with listing the original term and then figuring out what am I doing to get the next term? Well, to get the next term, I'm adding 3. That's it.